Okay, so this problem deals with solving an ln function. So this is ln of 2x minus 3 plus ln of x plus 4 equals ln of 2x squared plus 11. I know it looks scary, but it's actually not that bad. So what you want to do is you want to look at these log properties, okay? And the one that matches it the most is going to be this one here, okay? You see, it says if you have a log x and a log y, okay, when you add them, the middle parts, the x and y, you just multiply. I call them middles. And I'll talk about that in a second, what that means. But anyway, so whatever the log of what you have, you just multiply those, as long as the bases are the same. If the bases were different, then you couldn't do that. In this case, we know these are ln, so that means all the bases here are going to be e, 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 right? They're all base e, okay? So that means we can do that. So if I look at the left here, the left side of this equation, all right, and I apply this rule, it says, okay, if you have two logs, okay, when you add them, you just need to multiply what's in the parentheses. So in this case, I'm going to have ln, okay, of 2x minus 3 times that by x plus 4, okay? And then the right side is going to stay the same. 2x squared plus 11, okay? All right, so that's the first step. So you notice here on the left, hey, I can combine the inside the parentheses by just multiplying them, okay? All right, again, I can do that because the bases are the same. All right, now the other property here that's not listed is that there is a rule that if you have a log or ln, doesn't matter, okay? Log of m equals log of n. Again, I can use this for ln as well. The log and ln, you can interchange the properties. They're the same thing. Okay. So if I have the same log, again, if this was like base 10 and this is base 10, right? If they have the same base here, okay, what I can do is I can just equal what's inside the parentheses. So that means m is equal to n. All right. And then I solve it. And that's what we have here. So again, notice that we have a base E and we have a base E. So we can just equal what's inside the parentheses, or I call them the middles. Okay? So, so in this case, we'll have 2x minus 3 times that by x plus 4 equals 2x squared plus 11. Okay? So essentially, I just used two properties here. This property and then this rule. Okay? All right? And then I just solve. So I multiply this out. On the left side here, actually, I'm going to pause and want you guys work this out. This is a good practice problem. Okay, good. All right, so when we multiply this out, right, we just use the FOIL method. We should get 2x squared plus 5x minus 12, okay? And that's equal to 2x squared plus 11, all right? Okay? And then now we just solve. So we have 2x squared and a 2x squared here, so we can subtract them, right? So I can subtract the 2x squared, subtract the 2x squared, and then those guys are going to cancel, okay? And that leaves us with 5x minus 12 is equal to 11, okay? Then we're going to add 12 to both sides. Okay, so that cancels, and that gives us 5x equals 23. All right, and then we divide both sides by 5. Okay, so our answer is 23 over 5. Okay, so again, I want to apply the two rules that we just mentioned, all right? So this one on the left side, we have ln of x plus ln of 2x minus 2 equals ln of x plus 4. Okay, so again, all the bases here are going to be e. And again, if it said log, it's the same thing, right? If it was just regular log, the base would be 10. Okay, unless they change it. Anyway, so since all the bases are the same, then I can apply the rules here. Okay, so the rule I'm going to use for this one is the second one here, which says, again, log of x plus log of y, or ln of x plus ln of y. You can combine what's inside the parentheses. Okay, so again, all of these are base e. Okay, and on the left side here, I'm just going to combine what's in the parentheses. Okay, so I have ln of x times x minus 2 equals ln of x plus 4. Okay, all right, so since I have the same ln, I can now apply this rule here. All right, so it says if log of m equals log of n, if they have the same base, then I can just equal what's in the parentheses or the middles. Okay, so I'm going to do that. So I have x times x minus 2 equals x plus 4. Okay, then I just distribute. So I get x squared minus 2x equals x plus 4. And then I move everything to the left and then factor. So I'm going to subtract x and then subtract 4. So subtract x and subtract 4. Okay, so that's going to give us x squared minus 3x minus 4, and then these guys are just going to cancel, leaving us 0 on the right. Okay, all right, and then we factor this, so we'll get x minus 4 times x plus 1 equals 0. Then we set them both equal to 0. So x minus 4 equals 0, and then x plus 1 equals 0. Okay. Then we solve. So x gives me 4 on the left here, and x equals -1 on the right. Okay. Now, normally what we do is we need to go and plug these back in to check to see if one of them or both of them are not a solution. So, let's see here. Okay. So remember I said, if we go back to this here, okay, we talked about if I plug in numbers for log, right? If it's 0 or below, it's going to give us an error. Remember? Because remember on the y-axis there is an asymptote. So same for the ln, okay? There is an asymptote coming down here on the y-axis. So that means that the graph can't pass that, okay? So if you plug in 0 or a negative number, it's going to give you an error. Okay. So if we go back to our problem, if we plugged in 4, we'll be okay because it's not going to produce a negative number. But if I plugged in -1 in there, so particularly this one, the second one here, -1 minus 2, okay, is going to give us -3. If you plug in, if you type in ln of -3 in the calculator, it's going to give you an error. Okay. So that means then -1 cannot be a solution. Okay. And only +4. So remember that. Okay. So the next type of problem, I'm going to do a little bit of background here, kind of set you up so we can do the next problem. So this one here is we're going to go from rewriting this from a log function to an exponential function, and then vice versa. Okay. All right. So how do we do that? Well, I have this little saying, okay, which is little to the right equals middle. Little to the right equals middle. Okay, what do I mean by that? So the little, the little I'm referring to is the 3. Okay, to the right, I'm referring to what's on the right side of the equal sign. This is to the right. Okay, and then the middle is what's inside the parentheses in the middle. Okay, so if I want to rewrite this log function to an exponential function, I just follow this statement. Little to the right equals middle. So in this case, I would get 3, okay? Um, so I have the base 3 to the right, so that means -2 equals the middle, which is 1/9. Okay? So I changed this from a log function to an exponential function. Okay? So little, which is the 3, to the right, so like saying to the power, -2 equals the middle, which is 1/9. Okay, so let's do that again. So this one is log of base b of 4 equals 2. So little, which is going to be my b, okay, to the right, which is going to be the 2. Okay, so it does this kind of like a shell. Okay, all right, so kind of a swooping here. So little to the right, so b squared equals the middle, which is 4. Okay, so why don't you guys try the next two there? Okay, so hopefully, so the next two here you should have written. So again, little will be my 2, to the right will be the x, and in the middle is going to be 6. Okay, now for the next one here, we have ln, right? ln of x equals to 4. So remember, if there's nothing written there, that's automatically a base e. Okay, so that's going to be e to the right will be 4 equals the middle here will be x. And that's it. Okay, questions on that? Okay, so this one we want to go from exponential function to a log function. Okay, so why are we doing that? Well, because sometimes if it's written in log function and we're not able to solve it, then we need to change it to an exponential function. Same thing. If it's written in exponential function and we're not able to solve it, then we need to change it to log function. Okay, so so in this case, I'm going to go from exponential now to log. So I know that I'm going to have a log. Okay, all right. And so in this case, my base is going to be my A. Okay. Remember, just remember that little phrase, little to the right. So my little was A, to the right was 3, right? That's my exponent. So I'm going to have 3 here. And then in the middle is going to be my 2.1, right? So then you can just say little to the right equals middle. And that's what this is, right? That's the answer to this part. So you can just do that check there. Okay, let's try it again. So this one I have 3 to the x equals 4.6. Again, I'm going to write log here. Okay, and then my base is going to be the 3. That's the base. Okay, so then equal sign to the right will be the power x, and in the middle will be the number 4.6. Okay, all right. So go ahead and try the next two there. Okay. All right. So again, we're going to write this from exponential to log. So hopefully you wrote this down. So we have a base e. So that means instead of writing log, we should put ln. Okay. So we have ln of e, or base e, I should say, equals to the right, which is 2.2. And in the middle will be m. Okay. So again, little to the right equals the middle. And then the last one here, we log base, our base is 4, to the right is 2, and then inside will be, or the middle will be 16. So 4 raised to 2 equals 16. Log base 4 of 16 equals 2. Okay. Okay, so this one we want to solve these problems. Okay. So as it stands, right, this is a log equation. We can't do it, okay, as it's written here. So that means then we need to go from a log equation to an exponential equation. Okay, so let's go ahead and see if we can do that part. Okay, we're going to go from a log equation to an exponential equation. So go ahead and see if we can set that up real quick. Okay, so hopefully you wrote down again. So we have log of base 5x equals 3. So hopefully you wrote down we're going to go from log to exponential. So that will be little, right? So that would be the base 5 raised to the third, little to the right equals the middle. Okay? All right, and this one we can solve, right? This 5 to the third, that's just 5 times 5 times 5 equals x. Put that in the calculator, and that gives us 125. And that's our answer there. Okay? All right. So why don't you guys try the next problem there? Okay. So for this one, we're going to do exactly the same thing. We're going to rewrite it because right now we can't solve it. But if we rewrite it as from a log function to an exponential, we can, hopefully. Okay. All right. So this one will have 3, right? Little to the right will be 3 square equals the middle will give us 3x minus 2. Okay. And so 3 squared is going to give us 9 equals 3x minus 2. Then we're just going to solve for x. Okay, so that gives us 11 equals 3x, and then divide by 3. All right, so then x gives me 11 thirds, and that's our answer. Okay, so let's see if we can try to solve this one. All right, so as it stands, okay, we are not able to solve it. So, well, we don't have enough tools. Um, but there is another way, but again, we're not going to go through that. But as what we have right now are limited tools, we can't solve it. So we're going to change this from an exponential equation to a log, okay, or ln. Okay, so let me just do the log first, and I'll just change it. So again, we have log, right, and then our base is e, okay, and to the right will be the 2x, and then the middle will be 3. Right? But again, since this is a log an e function, we need to change it from log to ln. So ln base e of 3 equals 2x. Okay? All right. So now this is something we can solve. You're like, how? Well, we just have ln of base e of 3 equals 2x. And we're trying to get, again, we're solving this. And we're trying to get x by itself. So the last step we need to do is just divide. These are being multiplied. So I can just divide both sides by 2. Okay? And then there's our answer. ln of 3 over 2 equals x. And that's it. Okay. Hopefully you had a chance to try this one. All right, so I'm going to follow exactly what we did on the last problem. So again, as it stands right now, with the limited tools that we have, I can't solve this. So I need to change this from an exponential function to a log function, or ln. Okay, so I'm going to have ln, and then our base is our e, right? To the right will be the 2x plus 1, and then in the middle will be the 15. So I got to just check e little to the right equals middle. Okay. All right, and then now I just solve for x. All right, so I have to get x by itself, so I just need to subtract 1 on both sides. And we have ln of 15 minus 1 equals 2x, and then divide by 2. So then x gives us ln of 15 minus 1 over 2. Now, I just wanted to warn you, do not try to subtract 15 and minus 1, because ln is it needs something in there, right? It's just not ln blank. It has to have something to calculate, okay? So don't try to do ln 15 minus 1 and say, oh, that's going to be ln of 14. That's not true. Okay, don't do that, okay? But this is our answer right here. All right, so this problem says we want to solve this, and it says 4 and e raised to the x plus 1 equals 5, okay? Now notice the problems that we did before this. Was there anything multiplied to that e? Was there anything in front of that e? If you look at the previous problems we did, there wasn't, right? This one didn't have anything, and this one didn't have anything. Okay. So in order for us to apply the rule, we can't have anything being multiplied to e. So what do? Well, we take it out. Okay, how do we do that? We just divide it. Okay. So we have to get e by itself. All right. So we're gonna just oops. We're just gonna divide 4 on both sides. Okay. And then we have let me just change this to 8 so it kind of works out nice, right? I'm going to change that from 5 to 8. So I'm going to divide both sides by 4. Again, I just changed that 5 to 8. So that gives us e to the x plus 1, and 8 divided by 4 will give me 2. Okay? All right? So now I can rewrite this, okay, from an exponential function to an ln function. So again, we do ln. The little will be e, to the right will be x plus 1, and then in the middle would be 2. Okay? And then I just solve for x. So then I subtract 1 on both sides. Again, I don't have to keep writing e there because it's automatically assumed that we know that the base there is e, so you don't have to keep writing e there. Okay? And then there's our answer right there. Okay? Okay. Hopefully you had a chance to try this one. All right, so again, in this case, we can't have anything multiplied to 10, so we have to divide that first. Okay, so in order to apply the rule, so I'm going to divide both sides by 2, then I have 10 by itself. So I have 10 raised to the 2x minus 7 equals 3. All right, so this is base 10, and it can be any base. It doesn't have to be 10, but it's going to be log. Okay, so log of base 10. Okay, so little to the right, so it'll be the 2x minus 7. And in the middle, oops, and in the middle will be the 3, right? Because little 10, um, oh, that should be 10, not log. In the middle, it'll be 10 to the 2x minus 7, and in the middle will be 3. Okay. All right, so now I just solve for x. So we're going to add 7 to both sides. Okay, so that's gone. Then we have log of 3. Again, if it's base 10, I don't have to write 10 all the time. It's just automatically assumed that it is 10. It is 10, okay? Plus 7 equals 2x. Okay, again, don't combine the 3 and the 7. They're two separate. All right, then divide both sides by 2. Okay, and here's our answer. Log of 3 plus 7 divided by 2 is equal to x. Okay, all right. Hopefully you had an opportunity to try this. Okay, so again, we want to get the 2 by itself as it stands. We cannot change it from exponential to a log function unless we get the 2 by itself. So we need to divide both sides by 6. Okay, so we get 2 raised to the x plus 3, and then 20 divided by 6 can be reduced to 10/3. Okay. All right, and then I'm going to rewrite this from an exponential function to a log function, right? Because I have a base 2. If it was a base e, then I would write ln. But it's not a base e, so I'd write a log. So I'll have base 2, And then to the right will be x plus 3, and in the middle will be 10 over 3. Okay? And then I just solve for x, so I'm going to subtract 3 on both sides. And then we get log of base 2 of 10 over 3 minus 3 is equal to x. And then there's our answer. Okay, so again, we have this, and we need to solve this ln equation or log equation. So we have ln of 2x minus 4 plus ln of x plus 2 equals ln of 3x squared minus 24. Okay, so my goal is to rewrite it in a way so I can apply this rule right here. Okay, that's my goal. So in order to do that, I need to use some intermediate rule, which is this one here. Okay, so if you have two logs or two ln's that you're going to be adding, you just combine the middles. So we learned about the middle, right? The terms in the parentheses. So that's what we're going to do. So again, I can only do this because all of the bases are the same. This is E, and this is E. At any point, if one of the bases is not the same, then I cannot apply this rule. Okay. All right. So they are the same, so I can move forward. So I'm going to have ln of base E. Oops. And then I'm going to multiply the 2x minus 4 times the x plus 2. And I have on the right side ln of 3x squared minus 24. Okay. Again, this is base E. Since I have the same base, now I can just equal the middles to each other. So the terms in the parentheses. So we have 2x minus 4 times that by x plus 2 equals 3x squared minus 24, right? Okay, so I'm going to multiply this out. So I have 2x and x plus 2. Again, you can just do the flow method, but I just like it doing it this way. It's pretty straightforward to me. Okay, so I'm going to distribute each term, and we'll get 2x squared plus 4x. Then distribute this. So you have to be careful. This is a minus 4x, and then negative 4 times 2 will also be a negative 8. That's a common mistake students make. They only do it to the first term, but they forget to multiply the negative to the second term. Right? And then the right side, I still have the 3x squared minus 24. Okay. Okay, so on the left side, the 4x and the minus 4x are going to cancel. So that leaves us with 2x squared minus 8 equals 3x squared minus 24. Okay, and then I'm going to subtract 2x squared on both sides. So that gives us minus 8 equals 3x, sorry, 3x squared minus 2x squared will just give us an x squared minus 24. Then we're going to add 24 to both sides. Okay, so then this is going to cancel. And we have x squared equals minus 8 plus 24 is 16. Right, so now we have a power of 2. That means we should have two possible solutions. So we're going to take the square root on both sides. All right, so that gives us the square root of 16 is going to give us plus or minus 4 equals x. Okay, now if I plug in the 4 should work out. Okay, but if I plug in the minus 4, I'm going to have 2 times negative 4 here, right? If I plugged in minus 4, I have 2 times negative 4 is negative 8. Negative 8 minus 4 is going to give me a negative 16. So again, I can't have a negative or a 0 in the parentheses. So that's not going to work. So the only solution I have is the positive 4. Okay?